Hello students, in today's video we're going to learn about solving linear equations. So at the end of this lesson you should be able to solve linear rational equations. So let's get started. So solving rational equations with fractions part 1. So what you'll notice in a lot of these problems is that we do have fractions, and I know everyone tends to hate working with fractions, so that's why we're going to deal with that first. So in all of these problems we want to get rid of all of the fractions. And the way we do that is by finding the least common denominator within our fractions. So with the LCD from 2 and 3 just so happens to be 6. If you're not sure how we got that, I just made a list of multiples for 2 and found out where they match. So 3, 6, 9. So obviously we found one at 6 already. So what we're going to do here is we are going to multiply the entire equation by 6. So again, we're going to multiply 6 to the entire equation, but it's really important that you pay attention to how we do this. Now, what we're doing is we're multiplying 6 times x, which is 6x divided by 3, equals 6x divided by 2, and then we just have minus 2 times 6, or 2 times 6, which is 12. So, what happens here is when we do this multiplication, it simplifies, and 6x divided by 3 is 2x, equals 3x minus 12. Now we're just solving like we usually would. So we're going to subtract 3x to both sides to isolate the variable. We have negative x equals negative 12. Divide by negative 1 to both sides. We are left with x equals positive 12. So example 2, we are going to take one small shortcut. So in this instance, the LCD between 3, 4, and 6 is 12. So like we did in example 1, we're going to multiply by 12 to the entire equation. So it's important to listen to my words because the text will not necessarily illustrate that. When we multiply 12 to the first expression, the x plus 1 all divided by 4, we know that 12 divided by 4 cancels out. And what we're really doing when we cancel out 12 divided by 4 is we're left over with a 3. So this is going to turn out to be 3 times the quantity x plus 1. So notice we merely simplified it. When we do the 12 times the second quantity, 1 divided by 6, we know that 12 divided by 6 is 2, and then we could just merely multiply that leftover, 2 times 1, to that middle, and notice how they're all aligning. This is aligning with the top portion here, 2 times 1 and with this portion up here, and then the last part. We're going to distribute that 12 to the quantity 2x minus 1, all divided by 3. You'll notice 12 divided by 3 leaves you with a 4. So we are left with 4 times 2 minus x. We're going to distribute, and we get 3x plus 3 equals 2 plus 8 minus 4x. So on the left side, we've already been simplified. On the right side, we can add 2 and 8. So that's 2 minus 4x. Now we are going to combine like terms. So I'm going to move the constants to the right, subtract 3 to both sides. You get 3x equals 7 minus 4x. We're then going to add 4x to both sides because that's what the inverse operation is of minus 4x. We get 7x equals 7. Divide by 7 on both sides, and we get x equals 1. So let's look at part 2. Part 2 is a little bit more tricky because now you see that we have variables on the denominator. So we're looking at the denominators of our fractions and trying to find an LCD between x and 3x. And in this instance, it's just 3x because that's what they both have in common. So we are going to multiply by 3x to the entire problem. So what that looks like is going to be, we're going to again distribute that 3x, so 15x divided by x equals 30x divided by 3x plus 12x. So now we're going to do some simplification, or simplifying. So the x's get canceled out, the x's get canceled out here, and then 30 divided by 3 is just 10. So we're left with 15 equals 10 plus 12x. We're going to combine like terms, so we're going to move the constants to the left-hand side. And we're left with 5 equals 12x. We're going to divide by 12 to both sides. Now notice we're dividing by 12 to both sides so that we isolate or get the x by itself. And we're left with x equals 5/12. Example 2, we do the same exact thing. There's only one variation of this. You'll notice that the denominator, 2x minus 2, looks like it could be simplified a little bit. So let's look at that. So this can actually become 3 divided by 2 times the quantity x minus 1, because they both had a 2 in common. The right side can't be simplified, so we're just going to copy that the way it is. And then of course we have our equal sign. So, looking at our denominators now, they all have a 2, they all have an x minus 1. So our least common denominator is going to be 2 times the quantity x minus 1 times the entire equation. This is where that shortcut comes in handy. We're not asking you to do all of the multiplication, we are asking you to simplify. So, you'll notice that 2 times the quantity 2x minus 1 is the same as what we're multiplying to the first fraction. So that entire thing gets canceled out, and you're left with a 3. And when you look at 2 times the quantity x minus 1, and you multiply that to 1/2, you'll see that the 2 will cancel out with this 2, and you're just left with x minus 1. And then when you do the very last multiplication, you'll notice that 2 times the quantity x minus 1 matches the denominator in the last one, the x minus 1. So those should cancel out, and you're just left with the plus 2. Oh, my apologies. It's 2 times 2, so that's 4. So now we're just solving for a common denominator, or just solving for x again. So we're going to subtract 4 to both sides because we have a positive 4 and the opposite is subtract. We have negative 1 equals x minus 1. Because this one on the right side is next to the x, we're going to get rid of that one. So we're going to add 1 to both sides. And so our final answer is x equals 0. So absolute values, we'll go quick because I know you've all covered this. Absolute values must always be equal to a positive number. So for this example here, we have absolute value of x equals 8. That means what two values that when I take the absolute value will give us a positive 8. So that would be 8, and that would be x equals negative 8. Because when they're entered into an absolute value, it will be equal to a positive number. So let's look at example 1. The best way to look at this is to just separate the equations, because we know that there's always going to be a positive and negative answer. So we have x minus 3 equals 7. Notice I kept that exactly the same. We're also going to do the same thing, but instead of it being equal to a positive 7, it's a negative 7. Then we're going to solve and find that x equals 10 and x equals negative 4. So I know the 10 probably makes sense, but if you look at negative 4, if we substitute that into the equation, we get negative 4 minus 3, that's negative 7, and the absolute value of negative 7 is 7. Example 2, notice we have an absolute value, but we cannot deal with the absolute value until we've simplified what we have in front of us. So in order for us to do that, we need to isolate that absolute value by subtracting by 4 to both sides. And we get the absolute value of 3x minus 2 equals 0. Now that the absolute value is isolated, now we split it. So we get 3x minus 2 equals 0. And 3x minus 2 equals what would be negative 0. But since there's no such thing, we just solve it. And we get x is equal to 2/3. Last but not least is example 3. It says absolute value of x equals negative 8. So the first thing we would typically do is split it up. But if you were listening to what I said at the beginning of the slide, I said absolute values, which the absolute value of x is, the absolute value cannot be equal to a negative number, and it is. So this actually has no solution. Now it's your turn. Try these problems and we'll take a look at it in class. That's all for now.